Now that I have the print NC machine, or CNC machine, done, that now allows me to work on another project, CNC related, that I've been meaning to get done. And that is upgrading my ShopBot PRT Alpha 96. This is a machine that I bought brand new in 2006 when I built the shop. It is a commercial class CNC router that absolutely devours wood at incredible rates. It will take a full 4x8 sheet of plywood and is currently equipped with a 2.2 horsepower 3-phase spindle manufactured by HSD. And we'll go ahead and I'll flip around and you can see what the machine looks like. Okay, so here is the main machine itself, right? We'll kind of back up so you can see it. The white piping there is for my vacuum plenum. I use some commercial vacuum motors to hold material or sheet goods down. I've got 10 zones I can work with. I'm not really happy with the performance of this particular configuration. This is one that I came up with after I nearly set my shop on fire with this machine a number of years ago. And I think there's actually a video about that. If I remember to, I'll put a link in either this video or in the description. I think it's called ShopBot Heal Thyself. At any rate, this machine uses geared stepper motors that are geared internally. It's open loop. It uses a rack and pinion motion system that, all things considered, is actually pretty accurate. I've had no complaints for any of the stuff that I've ever produced on it, with the exception of one time, and that's because I was doing two-sided stuff and I was way in over my head and I just couldn't get the task done. I have since learned how to do that, I think. We'll see, because I've got some other two-sided stuff coming up I have to do. Anyway, so the ShopBot is a machine of its time. And I say that because in 2006, machines like this were not common. I think Shop Saber was a competitor at that time in that price range, but I don't think there was anything else. This was the best bang for the buck, and even then, I think it was close to $18,000 delivered. And it's one of those things where I had the budget to build my dream shop and do one of two things: fill it with toys or fill it with tools to build toys. And I went the tool route. So I now have a machine tool that I will never be able to replace because it's too expensive. That being said, I can make it better. The biggest deficiency in the ShopBot PRT Alpha is its controller. The controller ain't so hot. It gets the job done, but there's issues with it. The control software that runs on the PC is still, in 2024, written in Visual Basic 6. And I know that for two reasons. One, I have developed software in that language for decades. And two, I know what all the error dialogues look like that are internal unhandled errors. And it screams VB6. That being said, it gets the job done, okay? The problem is the communication between the host machine and that controller is pretty dismal. I have not had the issue that others have had as frequently, but I've still had problems with it dropping communication and the machine stopping and losing position and all kinds of things. And when you're an hour into a job and it loses its mind, you start learning French. Let's just put it that way. And the existing controller really can't be upgraded. And I would like to do more and get more out of the machine. It will never pay its own way. It never has, and it certainly won't in the future. That being said, upgrading this thing is not cheap. In order to upgrade the machine, I have to basically replace everything electric with the exception of the spindle. All of these stepper motors I cannot use because they are programmatically tied in some fashion to the stepper drivers that are in the control box that is back over here. Okay. In fact, give me a second and I'll show you what the inside of that control box looks like. Okay, here is the inside of the ShopBot control box. Okay, you get the 4 drivers. Oddly enough, this machine considers the x-axis to be the long distance on the machine and the y-axis to be the short distance. Also, 0 is right over there as opposed to being here like on my print NC machine. I have no idea why. If you in the comments know why CNC routers are built like that, let me know. I'm curious as hell. Anyway, I can't use any of this stuff. The closed loop driver system that I purchased will not talk to those, or those drivers will not talk to those, or to the new closed loop system I've bought. And the controller certainly that I bought certainly won't talk to those. And it's basically proprietary stuff all the way down for whatever reason. The controller is actually this little board right there. In fact, let me see if I can't grab the old one. That's a slightly upgraded one that I did in, or that I bought in 2009 or 2010. It's a little bit faster, but it really doesn't add any capability to the system. Give me a second and I'll chase that thing down and you can take a look at what that controller looks like. Okay, there we go. That is the original controller that shipped with the ShopBot back in 2006. You can see there is not a whole lot to this thing. And it communicated via serial, USB serial. But I mean, keep in mind, Windows XP was the weapon of choice back when this was new. So my plans are to do a complete upgrade of the machine. This means, like I said, everything gets replaced. New control box, new stepper motors, new controller. I would also like to replace the spindle. Okay, let's look over here. This beast here, this HSD spindle, and I think I'm using a Yaskawa? No, Yaskawa, sorry. VFD. It's been very reliable. Anyway, I would like to replace the spindle with something that I can use automatic tool changing with, because that would really be nice. It would allow me to do not necessarily new things on the ShopBot, but certainly faster things. Tool changes can be a problem. That being said, I don't know where I'm going to get an ATC for it yet. The official ShopBot ATC system is around, I don't know, the last time I looked at it, it was over $12,000. And Daddy ain't got that kind of money. So I'm going to have to come up with something else. We'll see what I come up with. I'm also going to need to add cable chain to the system, because we'll flip around here and I'll show you what I'm talking about. I need to add cable chain because right now it uses an acrylic bow that holds all of the wiring and the vacuum hose. I think they did that because back in 2006, cable chain wasn't as cheap as it is now. And while crazy, janky looking, it gets the job done. I've never had any issue of this, and I ran a job for the Print ENC machines electrical enclosure on this a month or so ago, and it still flexes, no problems. I have seen them break, and when they break, they're no fun to fix. That bow, I think, is 8 feet long, flat. So one of the things I'm going to do is upgrade to cable chain. And that should be fairly straightforward. I mean, I've got this nice aluminum extrusion that, as long as I'm careful with, yeah, there's T-track in the bottom here, so I don't necessarily even need to bore holes in it to add that cable chain. And it's desperately needed on the side too, because I mean, you can see this pile of wire here that is just an utter mess because there's no wire management included with the machine, or it wasn't back then. So I've got plans for a run of cable chain down that side. It also is not self-squaring. It can't. Both of the X drive motors, and remember, this is the Y-axis, not the X-axis, while they have their own drivers, they're connected to the same output pin on the controller. So the controller cannot drive both axes independently, which is something you kind of have to do if you want to use CNC controlled auto squaring. I don't know if I'm going to take advantage of that or not. I've got the machine squared within a 0.5 millimeter across the entire diagonal run of the machine, which is like 2,700 millimeters. Measured corner to corner diagonally, the difference is a 0.5 millimeter. In order to remove that last 0.5 millimeter, I would need to move the stop block, which looks like this, on the other side back 1/4 millimeter. And I am just not willing to get out my dial indicator to move that thing back that tiny amount. It's just not worth it to me. So I mean, when the system is energized and it's pulled back against the stops on both sides, it's as perfect as it needs to be for square. So yeah, my plan, and I do have a plan, I even have notes on the plan, is to go to a Centroid controller. Centroid seems to be the popular go-to controller for ShopBot conversions, to the point where there is a gentleman named Gary Campbell who builds bespoke gearboxes and stepper motor kits to do just what I am doing. So I reached out to him and I bought one of his kits. It entails replacing all the stepper motors, all of the drive gears that are on the stepper motor shafts. There is some gearbox stuff that goes on here because the new motors are not geared, but the gear output needs to happen. And I think that's just about it. The other thing that I'm going to do is remove this. This is an air drill. It basically uses an output on the ShopBot to cycle a pneumatic drill. It's got a pneumatic actuator in here, and then it's got a palm drill basically bolted into the mechanism, and the trigger wired shut on the drill. So as soon as it gets air, it spins. I was sold on this because I was told that the bearings in this HSD spindle are not loaded for drilling. And I should, in order to preserve the bearings, I should buy this air drill. The problem is the cycle time on that drill is ridiculous. You can't peck drill with it. It's full plunge drill only, and it takes seconds to fully plunge and fully retract. The depth setting is done with this here, and it's almost the threads are so tight it's almost impossible to turn, so it's a real pain to adjust. And frankly I don't think the wear on the bearings in the HSD justify what I paid for that drill. Especially as infrequently as I've used the machine. There have been times where I'll keep this thing running, 16 hours on a weekend. But total time accumulated might be 200 hours, maybe. But if it's less hassle to use, I use it more. Anyway, that's the box with the gearboxes and stuff in it, and the Centroid controller. And the next, in that huge cardboard box over there is the new enclosure. I learned my lesson building the electrical enclosure for the Print NC machine. It's a nice enclosure, and it's easy to put together, but when you're building it out of 1/8 inch aluminum plate, it gets expensive really fast. There's probably $250 in just plate in that enclosure all by itself. And realistically, that's my problem. It's not anybody else's problem. But like most of the lessons that I learned, they're expensive. So that's why I picked up that enclosure on Amazon, and I think I got it on sale for 90 bucks. It's an 18 by 24 by 6 inch deep enclosure. And it'll fit all the needs I have. I will not be putting the spindle inside. The VFD for the spindle. The VFD for the spindle will stay outside the enclosure. It really doesn't have any business being inside there with the electronics. But I wasn't willing to argue the point with the existing PNC enclosure design. And as you can tell, I'm sweating. My workshop has no cooling at all. That door behind me is basically a sheet metal roll-up door that I cannot insulate because it's a roll-up door. So it gets really hot in here. I think the current temperature is probably 82 degrees, and the outside temperature is probably in the low 70s, probably low to mid 70s. Anyway, that's also going to contribute to how much stuff I can get done during the summer months. Because when it gets hot outside, it gets brutal right about 11:30 or between 11:30 and 1 o'clock. You can't be in this room. And especially with my newfound heart condition, I'm not willing to push those boundaries anymore. So that's the next project on the horizon. I will of course be doing it in parallel with all the other nonsense that I have going on. But this one's nice and pre-planned. It's incredibly well documented, the process for the conversion. So I don't anticipate seeing any problems at all. And the videos that I'm going to do for this should be good enough for someone else that has a cabinet shop or something, and then they have a PRT Alpha that's languishing in the corner, that they can go ahead and do this upgrade and basically end up with a brand new machine. And that reminds me of one thing that I wanted to talk about, is these rails. I think I talked about these previously. And we're going to move around here, move this, these rails, okay? I know I did in a previous video, I talked about these V rails. It uses a mild steel rail that's ground into a 45-degree bevel on both sides, and it uses these really nice V rollers that have eccentric adjustments so you can set them up properly. Well, you can't get the hardened upgrade kit that ShopBot used to offer for love nor money. They simply won't. They won't even give you any information on it, and that's fine. I mean, this machine is like what, 18 years old or something like that, and expecting support at this point would just be absurd. So I want to go to hardened rails because, like I mentioned earlier, or in a previous video, most of my work is done in like the first 24 or so inches of the machine, which results a higher wear on this portion of the rail than the rest of it. Well, I did some digging and I got some help from Gary and found the manufacturer of the hardened rails that were used in that kit. And this is a 3D model that I printed. And basically what you do is you clamp the new rail right to that. You use the holes that it comes with to drill mounting holes, and you're done. I will have to change the location of the wheels on the inside a little bit because I think we're putting it in like that so it'll spread it out just a little bit. It's probably going to move it out about 1/8 of an inch, and that's fine. But I will be able to get hardened rails on this thing for considerable cost, but it will increase the life of the machine quite a bit. And with that, I'm going to bid you kind folks adieu. Thank you for watching.